Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to look at another example of vectors application. In this diagram here, it shows an object. So this is an object. It has a mass of 300 kilogram, and the object is at rest and is supported by two cables here. So we have this first cable and the second cable. Find the tension vector in each cable. So the question is asking to find the tension vector. So this could be the first tension vector, and this could be the second tension vector. So we need to find these tension vectors and the magnitude of these vectors. Okay, so these are the two forces that act on the mass of 300 kilogram, and it is not explicitly mentioned in this example, but there is another force that is also reacting on this object, which is the force going in this direction, and this is called so I'm going to call this as vector F, and this is equal to m times a, where m here represents the mass. The mass is 300 kilogram, and a is acceleration, which is actually related to gravity, so we can change it to mg. So this is equal to 300 times gravity is 9.8 meter per second. So this becomes the magnitude of the force is now equals to 2940, and this is going in this direction. Okay. So okay, in this direction, in this direction, and this is going in this direction. Okay, so next we can start off by finding the components of the first vector, the x component and the y component. And if you look at this vector and its direction here, you can clearly see that the x component is going in this direction and the y component is going in this direction. So here we will have the right angle triangle, where the degree here is going to be equal to 60 degrees, because this is 30 degrees and this must be equal to 60 degrees because the sum has to be equal to 90 degrees. So based on this, you can find the component of x. So I call it x1, and this is the component for y, so this is y1. Okay. We don't know what's the magnitude of this vector, so but we can call it t1. The magnitude is absolute value of vector t1, and therefore based on that we can come up with an equation. So the equation is x1 over the magnitude here over the magnitude of vector t1 is equal to cos 60 degrees. So that's the first step that we can do. So next, x1 is equal to the magnitude of t1 times cos 60 degrees. This is actually just 0.5. I'm just going to replace that with 0.5. Okay, so times 0.5. Okay, next we will be looking at the second part here, which is finding the value of y1, the component, the next component, which is component y. So y1 over the magnitude of vector t1 is equal to sine 60 degrees. Okay, and therefore we can say that y2 is equal to sine 60 degrees is 0.866, about that value, times with the magnitude of vector t1. So that is y2, and because of that we can write down the vector as, so therefore vector t1 here can be represented as this is in positive direction, so this is also positive, so the value is 0.5 the magnitude of t1, vector of magnitude of vector t1, and this one is 0.866 magnitude of vector t1. Okay, so this is So this is the first component, component x, and this is the second component, which is component y. Okay. Alright, next we move on to the second vector. You can see that this vector here, it can be separated into its components. So this is the x component going in this direction, and the y component is going in this direction. Again, we have a right angle triangle here, where according to this diagram, the angle between this must be equal to 60 degrees. So this is x2. I'm going to call this x2 with respect to tension vector 2, and this is equal to y2. Again, we don't know what's the magnitude of this tension vector, and we can just call it as magnitude of tension vector 2. So we can represent it using this mathematical symbol here. Okay, so now following the same idea, I'm going to write down x2. Okay, so x2 over the magnitude of t2. So x2 over the magnitude of t2 is equal to cos 60 degrees. Therefore, x2 must be equal with the same value here, which is 0.5 times the magnitude of vector t2. So that is for x2. Next, y2 over the magnitude of tension vector 2. So magnitude of tension vector 2 is equal to sine 60 degrees. Therefore, y2 is equal to 0.866, and the magnitude of tension vector 2. Alright, so now I'm going to represent this vector. So vector of tension vector 2 is equal to, notice that this is going in this direction, so we have a negative sign to that, so it will be negative 0.5 magnitude of vector 2 times with magnitude of vector 2, and this one it is going upward, so it has a positive sign, so we are going to just write down that equal to 0.866 magnitude of vector 2. Okay, so that's our vectors t1 and t2. And then we have another vector that we should consider, which is this vector, so we call it f. So f is another vector where there is no horizontal component because it is going straight downward here, so horizontal component is 0, and since it is going downward, the y component here is going to be negative 2940, so negative 2940. So there you go, we have managed to get all the vectors involved written down as such. This is vector t1, vector t2, and vector f. Okay, let me just erase some part of this. Okay, now I hope that you notice the statement given in this example here, which says that the mass is at rest. So what is the meaning of that? So the mass is at rest. That means the forces that act on it are balanced, or in other ways, we can say that if I consider the x component here, so this is the x component, if I add up all the x component, the result here is going to be equal to 0 because the mass is resting here. Okay, so now I can create an equation based on that. So if I add up the x component, all the x component, okay, so I add up all the x component, therefore 0.5 t1, vector magnitude of t1, plus negative 0.5 magnitude of t2, plus 0, the answer should be equal to 0 because the mass is at rest here. Okay, so next, based on this, I can say that 0.5 magnitude vector of t1 will be equal to 0.5 magnitude vector of t2. and you can cancel out 0.5. So therefore you can say the magnitude of vector t1 is equal to the magnitude of vector t2. So this is the first result that you get over here. Next, we are going to consider this part here. So when you add up the y component, the result should also be equal to 0, because again the mass is at rest. So what we have here is we have 0.866 magnitude of t1 plus 0.866 magnitude of t2 plus negative 2940 must be equal to 0. And this is since the magnitude of t1 is equal to magnitude of t2, we are going to replace this with magnitude of t1, and then we can solve for magnitude of vector t1. Okay, so now I'm going to replace 0.866 magnitude of t1, so this is vector t1, plus 0.866. okay, replace this with t1 because they are equal, and this is equal to 2940. So based on this, you will see that I will have about 1.732. The magnitude of vector t1 is equal to 2940. Therefore, magnitude vector t1 is equal to about 2940. Okay, 2940 over 1.732. This is equal to about 1697.46. So that is the magnitude of tension vector 1, and the result here is equal to the magnitude of tension vector 2. Okay, so that is the first part. Okay, we have found the magnitude of each tension vector. Now we are going to use this answer here, and you can plug in into this, okay, into this part. So you can plug in into this accordingly, and you will be able to find the final answer for the tension vector. Okay, so we're going to do that now. Okay, I'm just going to erase this. Okay, so next we're going to plug in the result of our magnitude into the respective vectors that we have here. So for t1, for vector t1, this is equal to 0.5 times 1697.46. So the answer that you will get is about 848.73. So that is the component x of vector t1, and here you will have 0.866 multiplied with 1697.46, and you will get the answer is equal to 1470. For vector t2, you will see that we only need to have a negative sign. The result is the same to this, except that it has a negative sign to that. So that is negative 848.73, and the y component is the same, which is 1470, and so this is the answers that we are looking for. Alright, that's all for now. Thank you very much for watching.